Here we will discuss about projectile thrown on the inclined plane. Now here alpha will be the angle of the incline with horizontal, and projectile thrown at a speed u, making angle theta with horizontal. Okay. So the situation is like this. Alpha, angle of the incline, that's the horizontal direction, this is g acting downwards, and the projectile is thrown like this with the velocity u and making angle theta with horizontal direction. So this angle obviously will be theta minus alpha. However, so we have to find the total time of flight, and total time of flight means it will hit the inclined surface obviously, and maximum distance from the incline, maximum distance of particle from the inclined surface. Okay. Now next you have to find that the range on the inclined surface, and next is the condition for maximum range, that is the value of theta for maximum range. Okay, so it is the path like this. So you have to find all these conditions. Let's start again with a new diagram. Now we will choose a pair of axes like this. Here origin, and this will be x axis, this will be our new x axis, and this will be our new y axis. Okay, and the components of g we can decompose g into these two components, right? Obviously you know this angle is alpha, as this angle is alpha, angle of the incline. So this is g cos alpha, and this component is g sin alpha, and obviously this was u, and this angle is theta minus alpha. So that's this is u cos of theta minus alpha, and this is u sin of theta minus alpha. Okay, like this. Now, so the equations will be like, so as per this x axis and y axis, ux will be equal to u cos theta minus alpha, ax, here it's not 0, ax equal to minus g sin alpha. Achha. For the y axis, uy is equal to u sin of theta minus alpha, and so ay equal to minus g cos alpha. Okay, Now, if you look at the motion, if you look at this motion, there are, see, any two-dimensional motion, you can look at it like this: the projection on the y-axis and projection on the x-axis. Projection on y-axis, so for that, so whatever happens this way, there is suppose a parallel beam of light, so you are looking at the shadow of the motion on the y-axis. So if you look at the shadow of the motion on the y-axis, as this particle goes along this path, right, goes here like this, comes back, okay, it will reach a maximum distance from this surface, inclined surface. So the shadow, if you observe the shadow, it's, if you observe the y-axis motion only, right, shadow, that means the projection of the motion on the y-axis, so it will go up with velocity uy, and an acceleration downwards is equal to g cos alpha, and this is the maximum distance from the incline h. So h is the maximum distance from incline. Okay. Now, so if as it goes along this way, the shadow will go up, reach a maximum height and come down, right. So the time, the first question was the total time of flight. So to find the total time of flight, the if you look at the y-axis motion or the projection of the motion on the y-axis, that is sufficient to determine time. It doesn't matter whatever is going along in the x-axis. So the total time of flight is equal to total time of flight of the y projection. So it goes up at uy acceleration. So it's, see, if you throw a ball at velocity u, if you throw a ball with velocity u upwards, then it will come back in gravitational field. What is the time taken? 2u by g, right? Time taken is 2u by g, right? If you throw a ball upwards at u, and this is g acting downwards, so 2u by g is the total time of flight. Similarly here it is 2uy, right? See, u will be replaced by uy, that means u sin theta minus alpha divided by, see, this downward acceleration, this, it will be g cos alpha. So that is the total time of flight. Now maximum distance of the particle h. So this h is obviously uy square by, see, in case of this particle, what is the maximum height? If a particle is thrown from ground at a speed u, suppose, say, make a new diagram here. Suppose a particle is thrown from ground with a speed u, g, right? So what is the time to reach highest point? Time to reach highest point, u by g. What is the total time of flight? 2u by g. Okay. What is the maximum height? Maximum height is u square by 2g, right. So just extending the same concept, the same equations will be here for the projection of the motion along y-axis. So it is uy square by twice g cos alpha. Instead of g, this is g cos alpha. So it's u y square, u square sin square theta minus alpha divided by 2g cos alpha. That's it. Okay, now question number 1, 2 done. Next is range of the projectile on the incline. For calculating the range, you have to look at this projection of the motion along the x-axis. let's do it with this. So if you have a light beam falling, as the particle goes in this path, its projection will go along this path, right? So it's going along a straight line and it will end here, right? So that is the range. This distance is the range r for range, and it will start with a velocity of u cos theta minus alpha, and it will have a uniform retardation of g sin alpha. And from here to here it will take time, how much? This capital T, total time of flight. So to find out range, just here if you substitute in the equation of x, right, ux times t plus half ax times t square, u x means u cos theta minus alpha times t you will replace later on. Acha, so ax is minus g sin alpha, so this is minus half g sin alpha times t square, and here's what you get, the final expression for range. It's u square by g cos square alpha into sine 2 theta minus alpha minus of sine alpha. That is the final expression for range you will get after applying some trigonometric equations. Okay. So this is the answer to part 3 of the problem. Now what's part 4? In part 4 you have to find the condition for maximum range. Okay, so just look at this equation, you will get, see this only here theta is negotiable, right? You can negotiate with theta only. U is fixed, g is fixed, and alpha, angle of the incline, is also fixed. So for maximum range, there sine 2 theta minus alpha is maximum, that is it's 1. So 2 theta minus alpha should be equal to pi by 2. So therefore theta is pi by 4 plus alpha by 2. This is the value of theta for the range to be maximum. And the maximum range, we also find out the value of maximum range, r max equal to u square by g cos square alpha. So here you get 1 minus sin alpha. Okay. 1 minus sin alpha, let us do it here. So r max equal to u square, g cos square alpha is 1 minus sin, so 1 plus sin alpha into 1 minus sin alpha. Here you have 1 minus sin alpha, so that will cancel. So therefore r max is u square by g into 1 plus sin alpha. Now here just one more point you should note down, that if the incline is like, see, instead of the incline here, if the incline is like this, and rest all conditions are same, you have to throw the projectile at a velocity u making angle theta with horizontal, instead of the incline being like this is this, so that's angle alpha. So obviously this is g. Then here you have to find the, say, total time of flight and the range. So for calculating total time of flight, I can apply in that equation. So you will put minus alpha in place of alpha. That's it. Your job will be done, because it is downward inclined, so put minus alpha in place of alpha, and here that total time of flight, you get t equal to 2u sine theta plus alpha divided by g cos alpha, and for range it's u square by g cos square alpha. Now where has that gone? Range, see, always it's a plus here and a plus here, so it's sine 2 theta plus alpha plus sine alpha, and also the maximum range R max. Okay, for maximum range, condition will be, condition is that 2 theta plus alpha is equal to pi by 2. So therefore theta should be equal to pi by 4 minus alpha by 2. Note that there in the last case it was pi by 4 plus half of alpha, here it is pi by 4 minus half of alpha. Now what about the maximum range? Let's put that maximum range in the formula, u square by g cos square alpha, and to here it is 1 plus sine alpha, so obviously its maximum range is u square by g, say it's 1 plus sine alpha 1 minus, so this will cancel, here you get u square by g times 1 minus sine alpha. This is the condition for maximum range if it's shown there, if the incline is like this. But while problem solving, I'll suggest you most of the time, if you do not apply any formula, that's better to, it's better to develop your concept like this. Do not apply any formula and try to solve the problem. Applying formula, okay, after you I mean it's the last resort that you use some formulas, but some obviously you have to use, right, because in every time you cannot derive for maximum range and all those things. But however, to stretch yourself up to your maximum limit without using formulas,